So hi everyone, my name is Srikanth. I'm responsible for the data center, packet optical, and the managed product lines at IP Infusion. Today I'm going to talk about full stack of innovation in optical networks. What do I mean by that is how do we go from today's vertically integrated optical networks to a fully open optical network. Before we look into the different components, I would like to just briefly touch upon what are the key drivers and the key components that is enabling this transition. So if you look at operators' needs, capacity is of course top of mind. You need to increase the wavelength, per wavelength, and fiber capacity, as well as efficiency of the line system, having an open line system, open ROADM, which is interoperable between different vendors. That is another key aspect. And then the different coherent technology, the pluggable modules, which are evolving at a very fast pace. How do we take advantage of those innovations? And then in the future, how do you make your network all optical with a collapsed control and data plane managed seamlessly? So those are some of key things that operators are looking at. And if you look at the transition from today's integrated systems to an all open system, there are two key aspects I would like to highlight. One is the functional enablement, which means separating out the integrated components into pieces which evolve on their own, where you can leverage innovation from multiple vendors. For example, separating out the transponder technology from the line system technology. This was all one box before. The second key component for operational enablement of automation is open standard APIs. How do you define standard APIs to your devices, to the to the drivers, and to the components, so that it can be uniformly managed across multiple vendors. So that with that background, if you look at the building blocks of open optical networks, right? So what you have is open line systems or open ROADMs, and there are standards being driven by operators who are evolving this open line system. And then you have the packet side and the transponder side. So you take all these three components, and when you separate these out, you get choice through mix and match of different vendors. And then secondly, you get interoperability through the standard APIs that I talked about. And then the third thing is innovation. Competition drives innovation, and all the operators benefit from that. So that those are the three key outcome that we get out of open optical networks. So how do we, from a IP Infusion standpoint, how do you enable this at different layers of our stack? So we have this software platform, which my colleague Shaji talked about. So the OcNOS software platform essentially is built on these abstractions at different layers of the stack. So let me highlight some of the key abstractions here, right? So you have the orange box, which is the software platform. And then you look at two abstractions. One is called the hardware abstraction towards your silicon or ASIC. And then you have the TIE, which is a transponder abstraction interface. This is an abstraction which we co-developed along with TIP and multiple partners within the industry. This gives you a uniform interface to your coherent pluggable optics. And then towards the northbound, you have the standard open config based APIs to uniformly manage the device. So with these three abstractions, plus there are multiple abstractions within the platform itself. So using this, what we do is we enable multiple use cases. We enable the backhaul use cases, the metro ring, and the long haul use cases. And the control plane is full featured. We can do a pure layer 1 cross connect or a full featured layer 2, layer 3 MPLS or VXLAN applications. And there is built-in manageability across the different layers. So At the link layer, the optical layer, we have a full suite of performance and management applications. You can monitor the fiber, the coherent optics, and tweak the power, bit error, and all the signal to noise ratio can be measured and presented to the user. And we have applications which detect the fiber fault. Also, we are building analytics so you can predict when a fault is about to happen. And we have the automation framework, the controller framework to stream all this data and do higher level analytics. So that's the platform at a high level. Diving deep into one of the components, which is the TIE or the transponder abstraction interface. So one of the things we did with the industry and other partners is to evolve this TIE API. So if you look at TIE, what it enables is multi-vendor interoperable systems, right? So you can have transponder from vendor A and transponder from vendor B, both coexisting in the same system. So for example, you could plug in a CFP2 coherent analog transceiver into the platform from vendor A and a DCO module, coherent DCO module in the same system from a different vendor. So the magic happens at the TIE layer through a multiplexing layer, which can dynamically load the device driver from vendor A or B. And what we do is we take those device drivers, integrate to the overall software platform, provide a single interface to across the board so that no matter which pluggable interface you have, you get a single uniform interface and ability to manage the whole system. So this abstraction again provides multiple benefits in terms of plug and play across multi-vendor components, enabling interoperability as well as automation and management. So these are key components we saw which are being addressed through this abstraction. Moving on, I just wanted to highlight some of the key high-level features that we offer in the platform. So today we support 100 and 200 gig modules, coherent DWDM modules, and working on 400 gig and 800 gig as the next evolution. And we have deployments which go from a short reach 120 kilometers to long haul countrywide backbones. And as I talked about, the OcNOS platform enables a comprehensive feature set, including management of the optical line side. You can tweak and play with all the common modulation, power frequency, and measure your bit error rate, power, signal to noise ratio, etc. And we have a set of debugging and alarm capabilities integrated to the whole system, and all managed from a controller through a zero-touch provisioning. So we enable this complete platform, open up for multi-vendor choice, and some of the use cases that we have addressed are essentially a backhaul, increasing capacity to 100, 200 gig in your backhaul network, or your long haul or metro ring topologies. And the three key platforms that we have enabled or worked with at this point are the one from EdgeCore called Cassini. It's an 8-slot packet transponder. So you can plug in either an ACO analog or a digital coherent module in one of those 8 slots. The other one is a smaller form factor 4-slot called Galileo from Wistron. And similar combinations of ACO, DCO, and you can have 100, 200 gig lines going out of the platform. And then the one we are about to release and working on within the ecosystem and tip, it's called the Phoenix, or the layer 0 transponder, which is a pure 400 gig line transponder.
Hey, Srikanth, I just wanted to ask a question. I mean, obviously, having that tie abstraction layer there is really interesting, and being able to kind of use any transponder with any hardware is super cool. But oftentimes, those kind of abstraction layers end up with kind of a least common denominator for some features. So I wonder, specifically, what does that do for like the data presented from that transponder for analytics and things like that?
Yeah, so the the advantage of TIE is essentially so as you know, these coherent transponders are MSA compliant, right? So typically most of them have a uniform set of registers and attributes that could be managed. So the advantage of TIE layer is plug and play. You can bring in vendor A's device with a small driver layer which talks to the vendor's device, right? And then the vendor B's driver takes care of that communication. But all the intelligence is basically built on top of this. So within the OcNOS layer, we use TIE's API layer to essentially read, manage, and take out those attributes. And then on top of that, we build the intelligence like performance monitoring and the other analytics that you talked about. So it's basically a normalizing layer which presents or abstracts the different vendors' device driver details.
Right, right. So, but does that mean that all of the kind of rich information you would normally get directly from a transponder passes through that, or is there any kind of change or limitation there?
No, there is none. Actually, we enhance work with different vendors too. So as you pointed out, every vendor could have some proprietary info, right? So there is a standard set of attributes which is uniform for all vendors. And some vendors have proprietary attributes that we enable by working closely with that specific vendor. So one vendor can have, you can read out OSNR directly from the coherent module or read out the chromatic dispersion. Those, depending on the capability, we do enable and pass through to the higher layer. So we do not filter out anything.
Great, thanks.
Yeah, Chris here. I've got a question on the topic of ZR and ZR plus. Talking about transponders and I know you mentioned ZR. Are you guys planning to support ZR plus as well when that comes to term? And how do you think that kind of plays into the whole open, the open ecosystem?
Sure. So that's one of the advantage of this, the layers and abstractions, right? So we are working on, as we said, 400 gig platform. One is a pure layer 0 transponder where we work on the 400 gig coherent optics. But then you have other types of platforms that Shaji showed, 400 gig where it's a QSFP DD enabling ZR or ZR plus form factor. So from a software point of view, essentially, it really doesn't matter what the type of technology is, right? So we take care of that normalization through the driver interface. Most of these are MSA compliant. And so we read the attributes, set the attributes, manage the module, whether it's ZR or ZR plus. So given the right platform, we have the software to take care of the management of the specific attributes. So the short answer is, yeah, we are working on supporting both ZR, ZR plus in the next 400 gig platform. Okay, so for the sake of time, I'll move on to the next slide. Essentially, if you look at the goals of this whole thing, how we started, we want choice, innovation, in interoperability, but at the same time, we want to be presented with a complete solution, right? So I want all this to come together. And that's one of the key things we do as a solution provider. We take in this solution, I'm just highlighting, we take the coherent optics from a vendor, for example, like Lumentum is one of our key partner. And then we take the card from NEL with their DSP, XSP DSP, and then the platform from EdgeCore or Wistron. And then we basically use our operating system software platform to bring all this together, stitch this together through the various abstraction layers. And that's how you get essentially a single integrated solution, right? And what you see here is essentially the set of ecosystem partners that we work with to enable and deploy the solution. So first you separate out the components, have innovation at each layer, then we put them back together and give you a complete solution. So that's how we enable the full stack of innovation. Yeah, moving on. So that is what we are doing today, but looking out slightly into the near term and far future, right? So we are working with two key entities, industry forums. One is the Telco Infra Project, TIP. Within TIP, we are working on multiple subgroups. The one I'm highlighting here is the CANDI or the OPT. TIE is a key layer for us. We are using TIE as a key open API layer for multi-vendor interoperability and innovation. So we will expand, we are expanding TIE for 400 and in the near future to 800 interfaces. And then we are opening up the northbound interfaces, implementing open config for automation of this transponder platform, packet platform, and the line systems. And there is another forum that I would like to highlight called the IOWN, where we are working on their vision of all photonic network with applications like security and high definition videos. So that's essentially what I wanted to cover within this optical domain. If there are no questions, I'll pass it to my colleague, Daniel.
I know that was future looking, Srikanth, but I'm just, when you say all photonic networks, and then I see like cameras and cars and laptops and cell phones in the picture, I get a little curious. Because obviously we're not taking light to mobile devices, or maybe not obviously, but I guess we're not.
No, I mean, the goal is minimize the transitions between the electrical and optical domain, right? So you want to ideally have this concept of fiber as close to your end device or the edge of the network. And then typically route your wavelength or the basically the fiber itself. Instead of doing switching at the packet layer, you try to bring those intelligence close to the physical layer. So that's the high level concept, but of course there are multiple layers involved there.